Hello, so we are going to continue our discussion, but we're going to look at histograms this time. So we're going to use the exact same example we used in the previous one. Let me make this bigger, I apologize. It says Mr. Turner has two math classes. With one class he lectured and the students took notes. In the other class the students worked in small groups to solve math problems. After the first test, Mr. Turner recorded the student grades to determine if his different styles of teaching might have impacted student learning. I'm going to let you decide that for yourself at the end. So we've already found the mean, the median, and we found the mean absolute deviation in the interquartile range, and you were supposed to guess which class do you think was the class that got lectured to, and which class do you think is the class that worked in small groups and solved different math problems. I know my opinion, and I'm sure you have your own opinion. So it's all opinion, right? So first, we're going to make a histogram now of the data. And so here I have for class 1. So let's see, I want it to be black. So here is, so here is the number of scores. And this is sloppy, but I apologize. And I'm going to just draw my lines now. All right, and so here I'm going to do this in increments of 5. So here I have 70. Sorry, this is going to actually be 75. I'm going to start at 70 because it's in increments of 5. So my first value is 70, 75, 80, 85, and 90. So I don't even need as many as I drew. Okay, and so they're already in order because I used the information that I did from the last lesson, where I went ahead and put them in order to find my interquartile range. So I want to know how many values are between 70 and 75. There are 1, 2, 3, 4 values. So that's 1, 2, 3, 4. I'm going to draw a box here. 1, 2, 3, 4. And there is my first block. All right, so the next one is between 76 and 80. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. I'm going to change the color. Okay, and so this is 4, 5, 6, 7, 8, 9. So from here, sorry, I want it to be perfect because these are supposed to touch. Okay, pretend like that's touching. So they're supposed to touch each other, right? Because it's a histogram. And so next, 81 to 85. 1, 2, 3, 4. There are 4, so let me change the color. So, and there are, how many did I say there were? 1, 2, 3, 4. And this is back over here. So here. Now they're touching. All right, and between 86 and 90, there's 3. So one more time for the color change. Let's make it yellow this time. So 1, 2, 3 is here. And there's my histogram. So that's my histogram for class 1. What do you think? How do you think the values look? Looks like it's pretty even. Does it look like it's skewed? Let's go on. Let's do class 2 now. All right, so again, I'm going to do the exact same thing here. So this is the number, and I forgot to put. So down here was the scores. And over here was the number of scores, right? And the title was class 1. scores from Mr. I forgot his name already. And again, number of scores, and the scores are down here. So let's go ahead and just making marks because I haven't even counted yet. And I'm going to do the same thing. I'm going to do in increments of 5. So I'm going to make it bigger this time because I know I don't have too many. So this is from 70. So we have 75, 80, 85, 90. Those are the scores that I have. So from 70 to 75, again, I'm just using the information that I have, that I already have, lined it up. And so there's just one for that one. So get my block and just one from 70 to 75. Okay. And then from 75 to 80, there are 1, 2, 3. Oops. There's just 1, 2. So going up to 2, let's change the color. All right, from 80 to 85, we have 1, 2, 3, 4, 5. So change the color. This is 2, 3, 4, 5. And I apologize, guys, because I know this is not going to be too awesome because I drew it so everything is not equal. But thank you for bearing with me. So 86, 86 to 90. It's the rest of them. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do I have 12 over here? I hope so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It is the top of my thing. So I am going to go all the way up here, pretend like they're touching. And so clearly this one is more skewed, right? We have a skewed one here, and this one not as skewed as much. Probably can tell that maybe it might be a little even. If Dr. Case would have drawn things more evenly, it might be more even. So let's make a few conclusions. It says, which measure of center and spread is most appropriate to use? So in class 1, the mean and median are both appropriate measures of center because the data is nearly symmetric. Okay, so there's almost symmetric. We know it's not definitely symmetric, but either one of those probably could be used. Similarly, the mean, absolute deviation, and the quartile range would be reasonable measurements of spread. In class 2, the fact that the data is skewed to the left, and we can look at it again. Here we have it. Oops. Skewed to the left, right? Because my tail is over here in the left. So this skewed to the left. It implies that the median is a better choice, and the median is a better choice because we don't want to use the mean, because in the mean we use all the values, while in the median we only use that middle 50%. So the median and the IQR is a better choice to use. And I hope that this helps.